Welcome back. We've decided to go ahead and change locales today. It's time for another episode of Low Spec Labs. Let's go ahead and get started here, guys. Before we get started, I would like to go ahead and say thank you to everyone who has liked and commented. Thank you to everyone who has also already subscribed. If you're new to the channel and you enjoy the content, go ahead and click the subscribe button below or to your right, or double tap that screen, whatever method or platform you're receiving this on. This is a broadcast, boys, so open up your signals and receive my information. On today's particular transmission, we're talking about managing storage. This is chapter 14 of Sander Van Voigt's RHCSA EX200. Wow, quite a mouthful. I'm already tired from saying that. Let's start with hard drives. This information you're about to learn applies both to hard drives, NVMEs, SSDs, but we're going to use hard drives because that is the traditional name. It's easier to remember. A hard drive is a computer component that stores information. On that hard drive, it has what is called a partition table. A partition table is basically a lookup table that tells the hard drive where information is. That partition table can come in two formats, either MBR for master boot record or GPT. GPT stands for GUID partition table. GPT is the newer format and the one most modern operating systems are using. So to sum everything up, your hard drive has partitions. These partitions are either formatted in GPT or MBR format, and these partitions will hold your operating system information. Let's talk a bit more about that. But first, before we talk about the technology behind partitions, let's talk about why you would want to use them. What are some benefits to partition? Well, the first is they allow you to logically segment data. The second is you can use partitions to increase security on different systems. The third is it's easier to create a backup of just a single partition on a hard drive that contains a database versus backing up the entire hard drive that contains both the operating system, the database, maybe some virtual machines. And last of all, partitions allow you to separate your storage into pools. So you can fill up one pool, and even though that pool is full, it is not your entire hard drive that is going to be full. You still have a little bit of remaining space there. So it allows for better data management. The MBR is generated from the BIOS. So BIOS stands for Basic Input Output System, and it's basically, and your BIOS is the interface that controls your low-level hardware devices like your hard drive and maybe your keyboard before you boot into the operating system. From the BIOS, you format a hard drive into a MBR or a master boot record. So what the MBR does is it splits the hard drive into various logical sectors and keeps information about those different logical sectors. You can also install different operating systems on those logical sectors. So for instance, you could have Windows and Linux on the same host and have them boot independently. You know, when you power the computer on, you just choose which one of those systems you want to boot. The MBR is generated from the BIOS. So BIOS stands for Basic Input Output System, and your BIOS is the interface that controls your low-level hardware devices like your hard drive and maybe your keyboard before you boot into the operating system. From the BIOS, you format a hard drive into a MBR or a master boot record. So what the MBR does is it splits the hard drive into various logical sectors and keeps information about those different logical sectors. You can also install different operating systems on those logical sectors. So for instance, you could have Windows and Linux on the same host and have them boot independently. You know, when you power the computer on, you just choose which one of those systems you want to boot. MBR, because it is so old, comes with various limitations. For instance, it only lets you use partition or disk size up to 2 terabytes. NBR also only allows you up to 4 partitions. This is very troublesome when on modern systems you might need many more than that. NBR gets around the 4 partition limit by having a special partition called an extended partition, and the extended partition can then be subdivided into logical partitions. These logical partitions and your 3 primary partitions allow you up to 16 partitions with an NBR boot record. Because of these limitations of NBR, we swapped over from NBR and we joined teams with GPT, not ChatGPT, but GUID partition table. In order to use GPT, you have to have UEFI. So many dependencies. What is UEFI? UEFI stands for Unified Extended. UEFI stands for Unified Extended Firmware Interface. It is the newer version of BIOS, and it does the same functionality of BIOS, but it comes with a lot more features. Things like mouse support, networking support, as well as other things like GPT hard disks. So many features. The key thing to take from that list is the fact that UEFI provides GPT hard disk support, since we are in fact talking about hard disks in this particular video. GPT also has a lot more features over something like NBR. For instance, the maximum partition size on GPT is 8 zettabytes, so you won't be running out of partition space anytime soon. GPT supports up to 128 partitions. There is no longer a need to differentiate between a primary, an extended, and a logical partition. And GPT also uses a unique 128-bit ID to identify partitions. In our last couple of videos, we've been talking about a bunch of acronyms, stuff like BIOS, NBR, GPT, and UEFI. If you're getting into IT, you're going to have to get very comfortable with acronyms, and those 4 acronyms all reference storage. At least that's how I tag it inside of my mind. Now that we know what partition tables are and the different types of partition tables, let's go about actually partitioning a disk or drive on a Linux system. We have a test node here. I'm going to walk you through me adding that test node, and then we're going to use one of 2 utilities to practice with. We're going to use gdisk, which is a newer utility meant to create GPT partitions, and we're going to use fdisk, which is the older utility from way back in the day to make NBR and GPT partitions. To either your left or your bottom, you'll see the configuration of this virtual machine. More importantly, you should pay attention to the hard drives. Look at that little orange hard drive right there. That is an additional hard drive I've added to this virtual machine. And we can verify the hard drives the virtual machine sees by closing that, going to our virtual machine, and using a utility called lsblock. And what that does is it lists the currently attached hard drives to our system. So as you can see, the virtual machine sees one hard drive named SDA and one hard drive named VDA. If we were to go back to our virtual machine config, you'll see we have SDA, which is SCSI 0, and we have VDA, which is VirtIO 0. But the additional hard drive we added, which is in orange, does not show up there. So how do we get that hard drive to appear? Well, first we have to reboot our virtual machine so that the virtual machine sees the hard drive. Let's go ahead and do that. So to reboot the virtual machine, I just do a quick reboot, and there we go. And it is now booting back up once again, and we're back. Okay, so now let's log back into this virtual machine. We'll go ahead and open up a terminal session, elevate to root. So we're logged back in, and we ran another lsblock after the machine has rebooted. You'll notice we now have SDA, SDB, SRO, SR1, and VDA. So the additional disk that got added right here as SDB. Why does the hard drive names change? Well, that has to do with naming conventions. So if we were to go right here, this hard drive VDAO is called VDAO because when we look at our virtual machine config, we have one VirtIO hard drive attached. Because that is a VirtIO hard drive, it uses a VirtIO driver, so when it is named inside of the Linux system, it starts with VD. You'll notice our other hard drives are attached via SATA and SCSI. Because it's attached via SATA and SCSI protocols, the Linux machine uses SATA and SCSI drivers to mount those virtual hard drives. And when we look at our machine again, you'll see we have SDB1 for SATA/SCSI device bus. We have SDA for that SATA device, and then we have SR0 for our SCSI device. So you can see the driver that the hard drive is using changes the name of the hard drive. So in that same way, if we had an NVMe, we would see dev/NVMe listed here, or NVMe N1 or whatever it's called. But before we do, I would like to take a few seconds and say thank you. Thank you to everyone who has hit the like button. Thank you to everyone who has commented. And thank you to everyone who has subscribed. I appreciate all of your support. If you are new to this channel and you like IT and automotive based content, go ahead and subscribe. This is just for you. If you don't like this content, I'm sorry to have disappointed you. Thankfully, we live in one of the freest societies on earth and one of the grandest ages of information ever known to man. You can take your time and do whatever you want with it. Like for instance, look at something else. Flip down, turn away. You don't have to watch things you don't enjoy. That is the best thing about freedom. And yet, you still tune in. Thousands of you do. Every week. 60 seconds at a time to learn Linux information. That is a strange way to learn. But who am I to judge? I'm the guy providing the content you're using to study. Not only that, but I'm a stranger on the internet. You don't really know me. You don't even know how good I know computers. I have a dark secret to confess to you boys. It shames me and it embarrasses me to admit this to you. But Mr. Low Spec is actually illiterate. When they brought me off the boats from Africa as a little boy, they never taught me how to read. I'm serious. I don't even know how to spell. But you've been making videos claiming you've been reading a book for 13 chapters, Mr. Low Spec. How can you have claimed that when you can't read? Why? I do the same thing as our corporate overlords like Ford, GM, General Motors, and GE. I outsource, of course. I pay a small team of Filipino men $5 an hour to take my raw scripts, render them using Sora AI and 3D models, cut them, edit into music, render them, and then of course upload them to my various social media platforms. For $5, it is a very amazing service. Contact me if you want to learn more. Let's talk about fdisk. What is fdisk? Fdisk is a command line utility that lets you manage Linux partitions. It lets you manage both NBR and GPT partitions. Fdisk is actually the older of the two utilities we'll be using today. It just got updated to support modern features. Before we continue, I would like to say thank you to Angelo, my Filipino editor. I appreciate all your hard work, bro. Let's try out the fdisk utility. First things first, we log in as root. We've already done that. Then we do an ls block to list all the devices currently attached to this host. So we have SDA, which is where our operating system is installed, and we know that because it says boot right there. We have SDB, which was the other disk we added, and we know that because it has 32 gigs. And then we have VDA, which is our VirtIO SCSI disk that was originally added, and we know that because it says V, and then because this is also a 32 gigabyte disk. Let's run an fdisk against one of these devices. So we're gonna do fdisk, hold on, come on computer, /dev/VDA. So now we've selected /dev/VDA. Let's use the M key for help. And what this does is it lists the different commands we have with fdisk. So we can delete a partition, list a partition, list known partition, add a new partition, change the partition table. There's lots of stuff we can do with fdisk. First, let's list how much disk space we have available on this disk. To do that, we use the P key. So this shows us we have 32 gigabytes available on this disk. From there, if we were to scroll back through the help menu, let's say we wanted to add a new partition. To do that, we use the N key right here. Your help menu is very useful sometimes. From there, it asks us what type of partition we want to make. You'll notice we either have a primary partition or an extended partition. We're going to go with primary for today. We're going to name this, or we're going to number this number 1. We're going to leave the default first sector. We're going to leave the default last sector, and there we go. And then last but not least, we need to save our changes. So to do that, we do W. And then when we run an ls block, you'll see we now have a new device underneath dev/VDA. That device is now VDA1. That is the new partition we just created. Now let's practice making an extended partition. We just filled up that disk, so we're going to use a different device this time. Notice we have /dev/SDB. It doesn't have any partitions assigned to it, and we know that because it doesn't have these little subdividers here like VDA or SDA has. Let's run an fdisk/dev/SDB. Let's see what happens here. Now what we want to do is make a new partition, so we hit the N key. This time we want to make it an extended partition. So we're going to use partition number 1 again. Partition number 1. We'll use the default first sector, right? And then we're going to minus 12 gigabytes real quick, right? So now we created an extended partition of 20 gigabytes. Now we'll run ls block. Oh, I'm still in the shell. So I was still in the fdisk shell. So first we have to quit that, and then we can run an ls block. And let's see what's going on here. I did not save changes. Oh my goodness. I'll leave this in. It's good to leave your mistakes in. So because I forgot to save changes, we have to do that again. So one more time. We do N for new. We do E for extended. Default once again. Default once again. And then we want to subtract 12 gigabytes from this partition size. After that, you want to hit W to write your changes. Then you want to hit Q to quit. Then you want to run an ls block. And now you'll see right there, underneath this, we have dev/SDB1. And notice something weird. This partition took up 32 gigabytes, while this partition is only taking up 1 kilobyte. Even though we set this partition to be a 20 gigabyte partition. What happened there? Well, this partition is a logical partition, so it doesn't necessarily take up all the space on the volume. I know that is a difficult concept to understand. I'll repeat it one more time. This partition right here is a logical partition. So even though it's defined as having up to, this partition right here is a logical partition. So you could consider it a pool of storage, meaning we've assigned up to 20 gigabytes of storage to it. But it's not necessarily taking up 20 gigabytes of storage. As we store more information on that partition, it will eventually take up 20 gigabytes and eventually get full. But because it's a logical partition, it doesn't automatically take hold of all the storage available on the backing store. In comparison to VDA1, which did take up all available space available on that partition, because it is an primary partition, not an extended partition. So we now know how to use fdisk to create primary and extended MBR partitions. But why would you make primary and MBR partitions on a modern system? Get with the time, boys. Stop being an old man. Like Mr. Low Spec, I age every day. I'm used to it. I should pop up a picture on screen from when I was a young man. I was 12 going on 30. What if we wanted to use fdisk to create a GPT partition instead of an MBR partition? The option for that is pretty simple. Let's look through our history real quick and see what this says about different options here. Look at that right there. If we hit G, we can create a new empty GPT partition table. So let's try that out. So let's try that out on fdisk. And notice the command I'm about to use here. /dev/VDA. Notice I didn't use VDA1, I used VDA, and then I hit G, and then after that I hit N for a new partition table. And notice the number of our partitions went from 1 to 4 to 1 to 128. So we'll call this number 1, and then it asks us for where we want the partition to start. We'll leave it that by default. And then what we want to do is we'll subtract 20 gigabytes from this one because we want this partition to be 10 gigabytes large, or rather 12 gigabytes large. After that, don't forget to write your changes. and then we have to quit. After that, we run an ls block, and notice here we now have a 12 gigabyte partition. That's very useful. It turns out fdisk is actually a rather easy utility to use. That said, one should go using it very lightly. If you choose the wrong hard drive, fdisk won't know you chose the wrong hard drive, and it will wipe all your information from that disk. And on Linux, there is no hard drive recovery tool, and this has to do with Linux storage and inodes, and a conversation for another day. Or maybe for later this chapter. I haven't read that for you. Otherwise, let's get started. Last time we left off talking about fdisk, which is an older Linux utility to create GPT and MBR partitions. Let's talk about gdisk. What does gdisk do? Well, it lets us create GPT partitions. The best way to learn a utility is just to use it. So let's go ahead and use gdisk and figure out how it works. So first we run an ls block to see what devices we have, and we're gonna run gdisk against dev/vda. So to do that, we do gdisk/dev/vda. Now you'll see gdisk lists some information here. It says it's found a valid GPT partition with protective MBR using GPT. Okay, let's hit the question sign and let's see what we get here. Let's see. So if we hit the question mark key, we end up getting a help menu, just like the M key with fdisk. Now let's look through some things we might want to do. The very first one is we might want to back up our GPT partition data. This is useful. We might want to change the name of partition. We might want to delete a partition. We might want to list detailed information about a partition. We might want to list known partition types. We can add a partition. We can create a new mtgud partition table, which is actually what we want. So what we're going to do is we're going to hit O, right? And what it's telling us is it's going to delete all partitions. Yes. And then of course, just like with fdisk, we have to save. So to do that, we do W and we save, and there we go. With that, we have just used gdisk to create a new mtgpt partition table. So we just use gdisk to reformat that virtual hard drive. What we can do is then use gdisk again to also format it to a new format. So again, let's hit the question mark for help again. And then what we want to do is create a new partition. So let's look through. Let's see here. So we use N to add a new partition. So we do that. We enter the partition number, which is 1. We leave the default. And then of course we want the last sector to be 10 gigabytes, right? And then you'll notice we have a different menu here. It says current type is 8300. So it currently says current type is 8300. Basically what the current type or the type ID does is it controls the partition format, right? So we can use regular Linux LVM, we can make this a swap, or we can make this a regular Linux file system partition type. Let's go ahead and proceed with that. So go ahead and hit enter to make it a regular file system. Then we have to save our changes. Then we proceed. Then we want to rerun a gdisk/dev/vda, right? And then what we want to do is use L. So we're going to want to look through, and then what we want to do is view our known partitions. So let's see which option that is here. So we can use P to print the current partition table. And you see how it lists the partition there? So what if we wanted to add a new partition? Well, that's easy as hitting N, right? We'll leave this as a regular partition. We'll make this a 1 gigabyte partition. Leave the first sector default. We'll make this 1 gigabyte. Okay, there we go. So we added a 1 gigabyte swap right there. Now it's asking us for our hex code. We want to make this partition a swap. So basically we want to make this partition additional RAM. So basically we want to make this partition a swap partition. To do that, we'll do 8200. And swap is a temporary storage location for memory objects. So it'll take stuff in RAM and place it on slower storage like your SSD or hard drive when you run out of memory. Then we hit W, then we write. Now when we run gdisk and we run a P to print the partition table, you'll see we now have a 1 gigabyte swap. And we can also see that 1 gigabyte swap when we run an ls block. You'll see right here, we now have 2 partitions, VDA1 and VDA2. And with that, we are done with our discussion with gdisk. Please feel free to tune into my next episode where I discuss LVM. We just went over how to make partitions. Congratulations, we've learned so much. Let's go ahead and proceed and talk about file systems. So partitions by themselves aren't very useful. Where they become useful is when you slap a file system on top of them. So you could look at the physical hard drive, then there is the partition table on top of that, then there's the partitions themselves, then there's your file system, which is where your actual data is stored and kept. So essentially a file system could be considered a database of records of where all the different files or blocks of information on your system are, where those files begin and end. There are actually a bunch of different Linux file systems, and like with most things on Linux, they each have their own pros and cons. There's only really 4 you should know, or rather 2. The first is XFS. The X doesn't stand for anything that never got filled in. And the older versions of X4, which include X3 and X2. How do you make a new file system on Linux? Well, the best way to learn is to practice. Let's go ahead and do that. How do you format a file system on Linux? Well, first you run an ls block to list all your devices. We already have the output of that right there. After that, you go ahead and you choose a device you want to format. In my case, I'm using dev/VDA1, which is right here. It's that partition we just made in that previous video. Then you run a makefs.ext4 and you point it to the partition you want to format. So if you're eagle-eyed, you'll notice we got an error when we ran that command. How do we verify that our file system got created? So how do we verify our file system got created? Well, to do that, we'll do tune to fs-l/dev-VDA1. It gives us some information. One, it tells us that the file system has a bad superblock, so we might want to reformat that. But it also tells us that the file system contains a XFS file system. So some useful information from that command. So once again, we use make.xfs to make our file system, and then we use tune to fs to verify details about it. Let's talk about mounts. Well, before we talk about mounts, let's talk about how file systems work, or how hard drives work. So remember, the very first level is the hard drive itself, and then sitting on top of the hard drive right here is your MBR or GPT partition table. Then on top of that is your file system, and then on top of that is your mount. So we're talking about the very highest level of your Linux file system here. That leaves the question, WDF is a mount. If you've been paying attention, basically a couple months ago we went over this topic. A mount point on a Linux file system is an access point for your underlying file system. So you would use your mount to access the file system on either your partition or the entirety of your hard drive. Okay, the best way to learn is to practice. So let's go ahead and clear this and let's practice mounting a file system. How do you mount a file system? Well, you have to use the mount command. Before we proceed with using that command, there are 4 things you need to know in order to get this command to work. To our left or to our bottom, we have a example /CFS tab. That is a good way to find out the 4 options you need when mounting a file system. Let's break those down. The first of those 4 options is what to mount. In our case, this would be this UUID. So we're identifying the actual serial number of the hard drive that we're mounting. So this is number 2. In our case, this would be this one right here, that /sign. The third option you need is your type, which is ext4. So this is an ext4 file system. And the last option you need are your mount options, which are these right here, which is like errors remount. So basically this is telling it to try to remount this file system and hard drive if it faces any errors. Let's go ahead and practice mounting a file system. First, you'll want to go ahead and log in as root. We've already done that. Then we'll want to list our hard drives. So let's run an ls block and choose a partition to mount. Let's see, we have dev/sdb1. So we're going to use dev/stb1 as the partition we're going to mount. Then we run a makefs.ext4 on dev/stb1. We hit a Y. We let it create that file system. So that's going to take a while. We'll come back in a few moments. And we are back. So that makefs just completed. So we'll run our ls block. You can see here we have dev/stb, and then we have dev/stb1, which is a 10 gigabyte partition. So again, we format that by doing makefs.ext4/dev/stb1, right? And like that, we are done. So now what we need to do is make a directory to mount our file system to. So what we do is we do make dir/temp/temp mount, and then what we can do is mount, and then what we want to do is mount our file system. So that is as /dev/stb1. Then we want to point it to our mount location, which is temp mount. Then we want to define the file system, which is ext4. Oh, there we go. So we do mount, we choose our source, we choose our destination. Now when we run an ls block one more time, you'll see we now have temp mount mounted, right? So before, when we first ran that command, you'll see we just had the disk label. There was nothing attached to it. Now when we run that command again down here, you'll see we have temp mount. What if we wanted to unmount our file system? Pretty straightforward. Once again, to unmount our file system, we would simply do a umount / and then this time we just point it to our destination. So temp mount. And then when we run an ls block, you'll see it's now no longer mounted there. Something to keep in mind is that when you mount a file system on Linux using the mount command, it will not, I repeat once again, it will not automatically remount that file system when you reboot. So how do we ensure our file systems are automatically remounted upon reboot? There is two solutions. The first is UUID, which is Universally Unique Identifier, and the second is RHCSA tab. So UUID is a method of identifying hard drives. Basically, it gives all the devices on your Linux system a unique serial number. This is important because these drive letters that are listed here might change. So as we add more drives to our system, this drive right here that is listed as drive/SDB1 might change to drive/SDC or SDD, depending on how the kernel feels that day. So to get around this problem, when we're defining our FS tab, which is basically a file we go to automatically define drive mounts, as we're defining our FS tab, we will use our universal unique identifier for these drives instead of their drive letters. We'll get into that subject a little bit more in just a few seconds. What if we wanted to get the UUID of this drive so we could write a properly configured RHCSA tab? To do that, we would do block ID. And as you can see, we have a bunch of different output here. We can get more specific and do block ID grep/dev/sdb1. And as you can see, this is the UUID of dev/sdb1. It even tells us the partition type and it gives us the label. But the most important information we want is this universal unique identifier right here. With that UUID, we can now edit our RHCSA tab. So the best way to learn is to let's dive into the FS tab. So if we were to clear our screen and then we were to do cat/RHCSA tab, you'll see the output of our RHCSA tab. And as you can see, we currently have some mounts defined. I showed you how to read the FS tab in our previous video or earlier in this video, depending on when you're watching this or how you're watching this. But basically, when we're defining an FS tab, the first thing we do is we define the drive location. You can do that by pointing it to the drive letter, or you can be a sane Linux administrator and use your UUID to define your drive. After that, you again choose your mount point, then you tell it the file system type, then you tell it the mount options, which is this right here, default 00. Now let's go ahead and practice modifying our HCFS tab. So first we want to get the UUID of the permanent. First we want to get the UUID of the partition we want to mount. So we block ID grep/dev sdb1. And then what we want to do is we want to highlight this portion right here. We want to copy it. And then we want to run a nano/HCFS tab. And as you can see, we have some file systems already defined here. So defining a new file system is as easy as typing in UUID equals, and then we paste that UUID we just copied. Then we point it to our temp/temp mount to our folder. Then we define the file system, which is ext4. We choose default mount options, and then we choose 00. Right now, when we reboot this host, it should come back up with the folder properly mounted. Let's see what happens, or it'll give us an error as it tries to mount. So let's watch the entire boot process and see what it does. Okay, and we are back. So let's go ahead and log in. There we go. Let's open up terminal and let's run an ls block again. And this time under dev/sdb1, you'll see we have a temp mount. And that is how you create a mount using HCFS tab. Before we go, I would like to say thank you for everyone who has tuned in so far. And thank you for everyone who has subscribed. If you like this content or you like this video, please go ahead and let me know below in your comments. Otherwise, I shall march forward and keep making these videos. I'm about to start chapter 15, which is about LVM, which is a favorite topic of mine because it is about software RAID. So we might start the conversation talking about what RAID is, and then we'll move from that into what LVM is and why it's a better solution for RAID over stuff you can buy off the shelf.